Welcome back on what's a pretty cold and snowy day outside the laboratory, but a good day to do some experiments and lighten up the place a little bit with LEDs. What I want to look at today is what light-emitting diodes are and some of their rather strange properties, and perhaps give you your first introduction to some quantum physics. So, when I was a young kid, I'd never seen LEDs, and it was only until a little bit later, when I was a bit older, we started to see them appear on electronic devices. They were usually on the TV to indicate whether it was on standby or not, or the light that used to flash on and off when the hard disk was operating on your computer. They were used to indicate whether something was working or not, and they certainly weren't used for lighting places up, and we certainly hadn't seen an LED head torch. But they were a bit expensive, so I had to wait until I could prize them out of old bits of electronics. And we got to the stage where you could start to buy them individually. And most of the ones we saw were red LEDs. We didn't until later see the green ones. And it was only until much, much later, I think I was almost at university, that we actually saw a blue LED. So it rather surprised me what was going on here and why did it take quite a while for different colours to appear. But what I'd like to explain to you first is some of the experiments I did when I was quite young and some of the strange things that I found out about LEDs that at the time I couldn't explain. So here goes for the first experiment I did when I was a kid. I got myself a red LED and I probably prized this out of some electronics that I'd found lying around, and some batteries. And I wired up the LED to the batteries, and I knew something about how to wire it up. So I plugged it in, and I noticed something rather strange. That if you just bought a single battery from the shops, what we might call a single cell in physics, and plugged it in, nothing worked. It didn't light at all. But if I used 2 in series, or 3 in series, or 4 in series, a higher voltage, it worked perfectly. But never mind what battery I bought, single 1.5 volt battery, it never lit up at all. This was very strange and I couldn't explain it. And I'll try today to explain to you why that's the case. You'll also remember, of course, that LEDs only allow current through them in one direction, and if you swap the wires round, they don't light at all. They're a one-directional electric device. But remember, I've got it the right way round now, but with a low voltage, it just won't light at all. Rather strange, and it took me quite a few years to find out the explanation for this. So I had red LEDs to play with, and I made the assumption that this red LED, when it's off, looks red. So when I switch on, it goes red. So it must be the case that's making it give out the red light. I thought the same thing about green LEDs. So later on, I got hold of a green LED, connected that one up, and I thought, oh, okay, it's got a green plastic case, so that makes it green light, a bit like a light bulb being painted with that colour. And then I came across some clear LEDs, and I thought, oh, okay, that's interesting. If that's a clear LED, that must give out white light. And I was really surprised to see that it gives out red light. Or perhaps another completely clear cased LED, and this one gives out blue light, the one that I didn't see until a bit later on in my career. And of course, if you had these muddled up in your toolbox, in your electrical components box, you wouldn't actually know which colour they were at all. So I'd made a mistake. And the mistake I'd made was to think that the colour of the plastic is what colours the light coming off these. And it's nothing of the sort. The case can be completely transparent. The colour of the light is governed by a quantum process that's actually happening deep inside the LED. So I've got a bit of a challenge now to explain to you 2 things really. Firstly, why did the LEDs never light up when I only connected them to one battery, one cell, 1.5 volts? They just never worked. And also, why did the colour of the case seem to have nothing to do with the colour of the light coming off it, that a completely transparent LED could give out coloured light? And it's this quantum process I want to explain to you. So, here goes for an attempt to explain what's happening inside an LED. By its very nature, any quantum process is difficult to describe in words and is going to be a simplification, but it helps me understand how LEDs work. Inside any LED is a semiconductor junction, and what this behaves like is a step on a staircase, or some of my students like to think of it as a cliff, a high point and a low point. Now, if you throw a stone off a cliff, it will never go halfway down and hover somewhere in between. It's either at the top or working its way down or at the bottom. And in the case of an LED, charge carriers do a similar sort of thing. They're at the top and they go down to the lower level. But if they don't have enough energy for that drop, then they can't hover in between, so they can't move. They can either be at the top or the bottom, needing enough energy to do that. And if they haven't got enough energy, they'll stay at the top and the LED won't conduct. And do you remember when I connected it into 1.5 volts, it wouldn't light up or conduct at all? That's because the charge carriers haven't got enough energy to make the transition from the high point to the low point. They'd be left hovering somewhere in between. And the very nature of quantum physics is that things are in steps, they're in discrete energy levels, when there isn't a position in between. You're either at a high point or a lower point. So, if the energy isn't large enough, the charge carriers can't be left between two places, so they don't travel at all. But if I give them enough energy, they can pass from the high point to the low point. The LED conducts and lights up. So we've got one other problem to explain. If you remember, when I was a schoolboy, I thought green LEDs were green because of the green plastic case. And it was only when I saw colourless LEDs that I was really surprised, and I had to question that a colourless LED might give out red light. Well, the explanation for this is a quantum one yet again. If you remember those quantum levels or quantum steps, in an atom, in the electrons that orbit the nucleus, they too are in different levels. You probably learned at GCSE they're in shells. And if an electron is in a high energy shell and it drops a small distance, it can't be in between those two places. It can only be in a high energy level or the next lowest one. Then it gives out a photon of light as it drops. And if that energy level is a bit bigger, it gives out a higher energy photon, and higher energy photons are green. But if an electron happens in the LED to drop from a high level right down to a much lower level, it gives out an even higher energy photon of light, and that's blue. It can't ever drop between levels, and I had to wait for quite a long time before they'd made a semiconductor junction that had the big enough and the correct level change for blue light or blue photons to be given off. So the case is colourless. What determines the colour of the light from an LED is what level the electron or charge carriers fall down as they pass through the LED. Is it a small step, red, a larger step, green, or an even larger step, blue light photons? It's perhaps worth me saying that in a head torch, of course, you've got white LEDs, and this is a completely different process. White light, you might know, is made of at least three colours: red, green and blue. It's a mixture of colours, and therefore you can't have a single energy level in an atom that represents white photons. There's no such thing as a white photon. To get white light, you need three different colours mixed. And one of the ways you can do that in an LED is build it such that there are three semiconductor junctions in here. One of them fires off with the low level, gives off red, another one gives off green, and the third one gives off blue. And those three photons come out at you, and you see them with your eye as white. So, I hope you've learned a little bit today about how LEDs work and how we get the different colours from them. But I suppose the most important thing that I described today was the fact that in quantum physics, in quantum processes, things come in discrete levels, discrete amounts of energy. You can either be at one energy level or another one, but never in between. So, I've enjoyed playing with the LEDs. I hope you've enjoyed watching this, and I look forward to seeing you again next time.